Hello, this is 5.1 notes. You notice I'm on the back side, so you should have already copied these down, and now I'm going to explain them. Ready? Here we go. We have Newton, Lagrange, and Leibniz. Newton was English, Lagrange was from where? Yay, you can tell my accent. He was France, and Leibniz is German, okay? So these guys kind of all invented calculus, and we're going to have a fun day the day before winter break where we have a cookie party and we eat Fig Newtons and Leibniz cookies, and we have a debate. It's not really a debate, like an activity to see who invented calculus. Was it Newton or Leibniz? And I'm not sure if it's Leibniz or Leibniz because I've never taken German before, okay? We know that we already have seen these three notations. A notation is how to write something. We have f, f prime, f double prime, y, dy, dx, and then the second derivative here, y, y prime, dy double prime, sorry. Okay, you ready? Position, this is position or particle motion. So particle means it's a little particle, a dot, like an atom, just like a particle that you see in science. And this particle is moving to the right or to the left. The particle is not on a function that you've graphed in the past. So it's not on one of these. It's not going up and down. Whee! It's not doing that. It's only moving forward and backwards, like a bead on a string, or like a train on a train track, or in class I'll demo me walking. Okay, I'll be walking forward and walking back. It's very Mickey Mouse. This is very like kindergarten level physics, okay? ABCs, very basic. So if you ever think it's too hard, you need to ask for help because it's not supposed to be. It's, if I can do it, anyone can do it, okay? Okay. So here's the big idea. Ready? Big idea next couple days. If the original function is position, then the derivative of position is velocity. Okay, the first derivative is velocity, and then the second derivative is called acceleration. So if you have seen these in physics before, you were just given the formulas. So you were just given, watch, say you were given the position formula of 2x to the power of 3. Your teacher said that's position. Well, then what would be the velocity? 6x squared. And what would be the acceleration? Okay, so you were given all three, and you were just told, use this for position or height, use this for velocity, use this for acceleration. But now I'm telling you, or you should, maybe you're realizing now, oh, that's the first derivative of this, and that's the acceleration is the second derivative, okay? Okay, here's some vocab that we have to make flashcards for because we have to have it memorized. We're going to see the word initially. Okay, we're going to see that word a lot, and that is code for t is 0. So if you go, oh, initially they're telling a really nice story about the beginning of something, it's not a story to the mathematician says t is 0. So that's going to be like an important clue. If the velocity is 0, then the position is at rest, and we're going to see that going the other way. So you might have a question say the position is at rest. You need to know that the velocity is 0, so it's stopped. It's not going forward or backward, okay? If the velocity is what does this say? Greater than 0, so positive, then the particle is moving to the right. And if the velocity is negative, the particle is moving left. You could also say forward or backwards, okay? But we're on the x-axis, moving right and left. All right, what happens if the velocity changes from positive to negative? So positive, it was going to the right, and then it goes negative, so it stopped, turned around, and went the other direction, okay? If velocity changes from negative to positive, then the position of the particle changed from left to right. But haven't we seen this before? When the first derivative changes from negative to positive, it's a minimum, yeah? But now we're going to say it changed directions. Okay, speed. We've heard of speed before. So velocity is speed with direction. So speed would be velocity without the direction. So that means the absolute value of velocity. Remember, a positive velocity means what? It's moving which way? To the right. But if you have a negative velocity, like -3 meters per second, that means it's moving to the left, but it's still moving 3 meters per second, just in the left direction, backwards. So speed is the absolute value of velocity. I will demonstrate this in class, okay? Velocity and acceleration, if they have the same sign, then the speed is increasing. But if velocity and acceleration have different signs, they're opposing forces, they're going against each other, then the speed would be decreasing. So if velocity and acceleration have the same sign, it's moving to the right and the acceleration is helping it move to the right, then speed is increasing. And if those would be positive, positive. If velocity is moving to the left, acceleration is helping it move to the left, like wind is blowing it or the current is taking it, same sign, it's still increasing. The speed is increasing, but to the left, okay? Now, what if you're trying to go to the right, but a big gust of wind is pushing you to the left? Then you will be slowing down, yeah? Your speed would be decreasing. I'll demonstrate that walking in class. Okay, what does this say? Memorization on this quiz on this page soon. So what do you need to do? Make flashcards, okay? So like officially that's your homework assignment for this page. Okay, let's turn it over. Thanks for watching and listening. Here we go. I'm going to read this paragraph. Particle motion problems deal with particles that are moving along the x or y axis. Thus, we are speaking of horizontal or vertical movement. Position, velocity, acceleration of a particle's motion are defined by functions, but the particle does not move along the graph of a function. It moves along an axis. Most of the time, we'll speak of movement along the x-axis, so horizontal movement. In Unit 6 and 7, like two more are the next things we'll learn in January and February, we'll revisit particle motion, and at that time we'll deal more with vertical motion, but for now it'll be pretty much horizontal. Oh, that's what I just said. It's like I wrote this. In the lessons, we'll develop the ideas of Okay, so there's two types of velocity and there's two types of acceleration. On the prior side, I told you that velocity is the derivative of position, and we need to know that. But that's called instantaneous velocity, okay? Instantaneous. Because what is derivative? Derivative is what? The slope of the tangent line, but it's at a point. Remember that phrase, at a point? Yeah, so that means it's instantaneous. How fast is the particle moving at this instant? That's instantaneous velocity. Average velocity is the secant line, or the average rate of change. So we've seen the word average before, yeah? And we've seen arc, average rate of change. That's the slope, that's the average velocity. Okay, what's the average speed from here to here? And then you would just do y2 minus y1 over x2 minus x1, like that. Okay, so you have to be careful about the question. Does it say average velocity or instantaneous velocity? And then you might need to refer back to these formulas here. Okay, so here's a function for position, and this says to find the average velocity, and we're looking at time between 1 and 3. So do you see how we plugged in 3? So y2 minus y1 over t2 minus t1. Okay, I gave you the answers, so you have a choice. You have a moral, ethical choice. You can copy that answer down right here, okay? Or you can use this as a 5-minute opportunity to practice using your calculator, okay? So you just type this into the calculator screen and you try and get the answer, and you see the answer here. Okay, so what choice will you make? Okay, the instantaneous velocity, you have to find the derivative using product rule. Did anyone out there find the derivative yet? So derivative of what? You take the derivative of the position here and you write it down, and then you plug in 1.5 to try and get the answer. Okay. Same thing with acceleration, except what? What's the acceleration? The acceleration is the derivative of what? Velocity, and then we have the slope of the velocity would give us the average acceleration. So we have this beautiful mess. Try and find the answer, and then you got to find the derivative of velocity. Okay, so the acceleration is the derivative of velocity, and velocity is the derivative of position. Thanks for watching. Practice with the calculator to try and get these answers, and we're going to go on to more examples on the next day. What do I say to sign off? Smash that like button.